Bismillahirrahmanirrahim. Today, inshallah, I'd like to talk about factoring polynomials. Factoring polynomials. Okay, this is like what we did in Algebra 1 when we had a x squared plus 5x plus 6, and we factored this into x plus 3 times the quantity x plus 2. Okay, so going from here to here is what we call factoring polynomials. In this case, this is a second degree polynomial. Now we're going to do a little bit more advanced factoring of polynomials. First thing we have to do here is arm ourselves with the knowledge that we have. And so the first thing is I like to remind you of and share with you what we have learned already of polynomial formulas, and I like to introduce you to two new formulas, and then after that we can jump in. First, if you must remember this: a plus b squared equals a squared plus 2ab plus b squared. Okay, this is a square of a binomial. Okay, and a minus b squared is a squared minus 2ab plus b squared. Okay, and we had a plus b times the quantity a minus b, and this was a squared minus b squared. Now these are basic and fundamental, and we must know these. Okay, and previously I had introduced to you the cube of a binomial, which is a plus b cubed, and the a minus b cubed. Now these are two formulas that we learned that were new for Algebra 2, and we said, see, these are squares of binomials, right? And these are cubes of binomials. So these two formulas are cousins of these. So these are cousins, so to speak, right? This is binomials that are squared. These are binomials that are cubed, okay? So you have to know these as well. So the quantity a plus b cubed is a cubed, okay, plus 3 a squared b plus 3ab squared plus b cubed. Okay, and a minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. The negative signs, the bookshelves at the two ends, and the positive being in the middle. Okay, so these are also very important. Okay, there's another set like this that I have to introduce to you today, and this is new, and after we have learned these, we'll be ready to factor polynomials, inshallah. And that is this: a cubed plus b cubed, okay, a cubed plus b cubed, okay, equals, and then you have a cubed minus b cubed equals. Okay, now look, if I give you a squared minus b squared, that is a plus b times a minus b, right? That's this going backwards. Okay, so all of these are pairs. From here to here, you're expanding, right? But if you go from here to here, this way, you're factoring. So expanding and factoring, all of them are both ways, correct? So these are going to be factored, okay? Because this is how we're going to see. So whenever we see this, we should be able to factor this. And whenever we're able to see this, we should be able to factor them as well, okay? So a cubed and b cubed, the sum of two cubes and the difference of two cubes can be factored, okay? They can be factored. So sum of two cubes factors as a plus b times a squared minus ab plus b squared. There better be a minus somewhere, right? Because, you know, how are you going to get rid of some terms, right? So there has to be a minus there. This is a new formula for you today. And then the difference of two cubes is a minus b. That's easy enough. So if it's plus here, there's a plus there. If it's minus here, it's a minus there, okay? Now, so the difference of two cubes is a minus b, okay, times a squared plus ab plus b squared. Okay, got it? So these are new, and I would really request you to diligently write this down a couple of times, or however many times it takes, and learn these. Okay, learn these. Okay, now, and I hope you appreciate that these are all unique. They're all different. This is a binomial cube. This is a binomial cube. These are the sum of two cubes and difference of two cubes that are being factored over here. Okay, we're going to use all of these today in factoring polynomials. This is our armamentarium, so to speak. Okay, and it's not challenging when you have mastered some of these basics. I encourage you to put a little bit of effort here, if you don't mind, inshallah. Okay, so let's do some problems, inshallah. I'm going to pick them from the book because it'll be easiest for me. So here's one. The next three examples that I'm going to do for you: x cubed plus 2x squared minus 15x. The next three examples that I'm going to do over here, they all illustrate one simple basic principle, and that is the first thing you always do is to see if there's something that is common to all terms. Okay, is there something that is common to all terms that you can factor out? In other words, you look at every single term like this and see if you can factor something out. So if you have 2x cubed plus 2x squared plus 4, you must immediately recognize you can factor out a 2 from all of these three terms. Okay, so that's the first thing you'll do, and these first two examples that we're going to do are going to illustrate that. Our instructions are to factor completely. Okay, that's our instructions. So here, the first thing, as always, is, okay, is there something that I can factor out from all of these three terms? Okay, so is there something that I can factor out from all of these three terms? Well, there is. I can factor out an x from all of these three. There's no constant term that I can factor out, but I can factor out an x, right? So if I take out an x, okay, from all of these three terms, I'll be left over here with x squared plus 2x minus 15. The x here would be factored out. Now here I'm left with the quadratic expression, which I can hopefully potentially factor out. So I have an x on the outside, and then I'm going to try to factor this out. So I put an x over here, and I put an x over here, and I look at, this is 1 and 5, the factors of 15, 3 and 5. Okay, I think it's going to be 3 and 5. Okay, 3 and 5. Okay. And the signs are different. The bigger product is positive. So this is 3x, and this is 5x. I have to make the bigger product, which is this one over here, positive. I'm going to put that positive and put this negative. Okay, so this original expression, x cubed plus 2x squared minus 15x, factors out 2x times the quantity x minus 3 times the quantity x plus 5. Okay, so the point here was, in this example, look for something that you can factor out at the outset. Okay, so here's another example. 2y to the 5th minus 18y cubed. Okay, let's do the same thing again. What can I factor out from both of these terms? Ding, 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 ding. What can I factor out from both of these terms? Well, I can factor out a 2. Okay, this is 18. I can factor out a 2. And I can factor out a y, can't I? Well, I can factor in fact a y cubed, because y cubed is common. This got 3 y's and got 5 y's, but at least they have 3 y's in common. So great, so I can factor out that. So I'm left with y squared minus, okay, 9, that's it, 9, right? So I've done that, but then you see, can I factor this further? And you should recognize, oh, this looks familiar to me. This is a plus b times the quantity a minus b, and this is a squared minus b squared. So this, the difference of two squares, okay, can be factored out as this. So, I got this. So then you say 2y cubed. Now this is going to be y plus 3 times y minus 3. And that is this expression factored completely. Okay, so here again the lesson was to see if you can factor something out from both all the terms initially, and to see what remains can be factored further. So here's a third example. 4z to the fourth minus 16z cubed plus 16z squared. Now, not all polynomials can be factored, as you know, but here this seems promising. Let's see, what can I factor out from all the terms? It looks like I can factor out 4, and z is common to all of them. Okay, factor out a z. Z squared, in fact, right? Okay, so I'm going to factor that out. So I'm going to be left with z squared minus 4z plus 4, right? 4 is 16, yeah. So am I done? No, but perhaps I can factor this out. Now you look at it, well, if you did not know that this is a plus, that is a minus b squared, that's, okay, it's a squared minus 2 times a times b plus b squared. Okay, now if you did not know that this would factor out into z minus 2 squared, that's cool. Okay, but so you would do this. That's fine. You can just work this out. Z and z. Well, 4 over here. Put a 2 over here. Signs are the same. They're both negative. Oh, so it's like this. So the answer is this, but you would write the answer as 4z squared times quantity z minus 2 squared. Now you would write the answer like this, not like this, okay, because these two are the same terms, so you kind of put them together like that, okay? So those are 3 examples. I like to do 2 additional examples before I finish, okay? And the first one is this: x cubed plus 64. Well, what is this? How am I going to factor this out, okay? Well, this is new. This is sum of 2 cubes, okay? This is a cubed plus b cubed. That's what this is. If I give you x squared minus 25, you should recognize this x plus 5 times x times the quantity x minus 5. You should recognize that, right? So soon enough, you should be able to recognize cubes. When you see cubes like this, you should know there's a formula for the sum of cubes and there's a formula for difference of cubes. And the formula for sum of cubes starts with a plus b. Then you have a minus ab plus b squared. B squared. A squared minus ab times b squared. Okay? So now this cannot be factored any further. Okay, so there's a formula for sum of 2 cubes like this. Okay, so in this case it's like this: x cubed plus the cube root of 64 is 4. So this is x cubed plus 4 cubed. Okay, now if you didn't recognize that, you have to start seeing things. Okay, so so this is a cubed plus b cubed. Let's go a times b. A plus b. A is x. So x plus 4 times x squared minus ab, which is 4x, plus b squared, which is 4 squared, 16. Okay, so that's that. Okay, so the answer is this. So this cubic expression factors into that. Now it's longer, right? But that's the way it factors. Now this you cannot factor any further. That's not a factorable thing. And the last example I like to do before I finish is this one, okay? 16z squared minus 250z, sorry, this is z to the 5th, 16z to the 5th minus, let me just label this so we talk about 2 separate problems, minus 250z squared. Okay, I'm to factor this. Okay, first thing is, well, is there something common to both terms? Yes, there is. I can factor out a 16. No, I can't factor out. I realize I can factor out a 2, okay? And I can factor the z squared. Then I'm left with 8z cubed minus 125. All of these are factored. Now, you look at this, you step back and look at this, you got it cubed over here. Then you should start thinking, hey, maybe this has got to be one of those cube formulas, the cube formulas. Maybe it's like a cubed minus b cubed formula. Maybe it's going to be like a minus b times, a squared plus ab plus b squared. Maybe I can make use of this formula finally, yeah? So, yes, it is. Okay, so this is, because here this is 2z cubed, that's a, because that's 8 and z cubed, and minus this is 5 cubed. 5 cubed is 125. Okay, that's b. So I can factor this out now. So I have the 2z squared, don't forget that, into all of this. Okay, so that's going to be a minus b, which is 2z minus 5 times the quantity a squared, which is this squared, 4z squared, plus a times b, which is 2z times b, which is 5, plus b squared, which is 25. So I just simplify this. So you have 2z squared times 2z minus 5 times the quantity 4z squared plus 10z plus 25. Okay, so this expression factors out to this. Okay, that expression factors out to this. So that's the difference of two cubes, and this is the sum of two cubes. And it seems challenging, but I request you to learn those formulas. Once you learn those formulas, you'll see these become not as difficult to see. Inshallah, I'd like to do some more problems of these kind next time. Until then, as-salatu was-salamu ala rasulillah wa ala alihi wa sahbihi.